solving these equations. So we want to first of all find all the angles that make this equation true. So secant x equals -2. One of the things we will do in solving equations is using our identities, and what we'll find is oftentimes it's a lot easier for us, because we know the angles and everything, if we convert statements in terms of cosine and sine. So secant x is 1 over cosine. So that is one of the reciprocal identities that we have. And why don't we just work with cosine, 1 over cosine, instead of making something new? Well, this gets used enough in some areas that they actually wanted to give it a new name. But this is the same thing. So we've used an identity, we've moved forward, but we're used to seeing like cosine x equals something. So how can we do this? Well, think of -2 as being -2 over 1. We could cross multiply, go through a few steps, but we've also talked before about how when you have two fractions equal, the reciprocals are also going to be equal. And so we can think of this as cosine of x equals -1/2 cosine x over 1, right? And so this is what we're going to do. And then we can just think, this is where we would use an inverse function, right? Or we could just think on the unit circle, where is cosine -1/2? That same thing would apply. But let's go ahead and do a process here. If I take the inverse cosine of both sides, so the inverse cosine of cosine is just going to be x, because those are functions that undo each other, right? They're inverse functions. And so then I can come over and use my calculator feature, and I can use the arcsine. What is the arcsine of -1/2? Well, it's 2/3. But the reason we don't want to stop there is, right, we want all the angles that make this equation true. And if you remember in our discussions of inverse functions, that the inverse, cosine inverse, only exists from 0 to pi, but there's another angle on the, so that's the top half of the circle. On the bottom half of the circle, that would also be a -1/2. So we see, 2 pi over 3. So thinking of the unit circle, what we're getting is we're getting 2 pi over 3, and then this would be the 60-degree angle, same 60-degree angle, 180 plus 60, right? This is going to be 2 pi over 3, 3 pi over 3, 4 pi over 3. Same angle. Those are the two places that is going to occur. So we did this and we found, 2 pi over 3 is one place. However, x can also be 4 pi over 3. But that's just one trip around the circle. If we go from here and we add 2 pi to it, we end back up where we started. Or if we subtract 2 pi, right, we would end up, so add 2 pi plus 2 pi. Or if we subtracted 2 pi going in the negative direction, that would work as well. So our answers are going to be that we will have the solution is x equals 2 pi over 3 plus or minus 2 pi or 4 pi or 6 pi, multiples of 2 pi. So then we do this thing with n. Some books will use the letter k, where n is an integer. 1, 2, or actually a counting number. It's not 0 because it wouldn't work. Well, I guess it would work at 0. This becomes 0, works at 1, 2. So it's a counting number, so n is of the set 0, 1, 2, 3, and so forth, however you want to define it. And then there's another solution that occurs at 4 pi over 3, and then we can add or subtract 2 pi and multiples of 2 pi. Okay. And another way that we go about remembering that there's more than just the one answer, because again, if you just put in the inverse cosine, you get one answer, you think you're done. It's always good to get an overview by doing the graph as well. So we won't necessarily do this for all of them, but in today's discussion, however, you may want to do this each time. So we're going to graph these two as separate functions, secant of x. So I'm going to add an element, add y equals x, and let's make that secant x. Go to our toolbox, and oh, there it is, it's secant right there. Secant x, and then we will also add y equals -2. -2. And then we are going to, oops, that didn't come out how I wanted it. -2. There we go. We're going to plot the graph. What this does is it shows where those intersections are. We can come here to the calculate feature, and we will calculate on secant, and we're going to have it find the intersections for us. And notice it's right there's an intersection, so we see that there's between 0 and 2 pi there are 2 intersections, and then we go above 2 pi, they're repeating. They're the same intersections, but they're repeating. So this number plus 2 pi, which is 6 and change, right, gives us to 8.23. So you can kind of see this, but it gives it all to us in terms of decimal radians. Okay, but it's a good way to see, yeah, there's a lot of intersections here, and that keeps going as we go on. All right, so we'll return this, clear this, and we'll go on to the next. So how about this equation? Now, one thing you might be tempted to do is, oh, we could just divide both sides by sine x, and then we get cosine x equals 2. That seems like a quick and easy solve, but remember, there's places where sine x equals 0, and when that happens, we have something that's undefined. And in this case, you know, sometimes it's helpful because it may get us a solution where sine x isn't 0. But in this case, cosine x is never equal to 2. The largest it can be is 1. The smallest it can be is -1. So this didn't help. Okay. So just remember, when we've got a variable, if you go to divide both sides, that variable, if it were 0, it gives us something that's undefined and doesn't get us a solution. So another approach to this is we see we've got a sine x and a sine x. If we get them on the same side, by subtracting, we'll have 2 terms, and we'll be able to factor out a sine x. Not only that, we will have 0 on one side. So let's do this. Let's get it equal to 0 by subtracting sine x from both sides, or 2 sine x. I'm going to bring it over here, so we're going to have cosine x, sine x. I like to have my x's in parentheses, minus 2 sine x, that equals 0. And now we've got 2 terms, each with a sine x, so that can get factored out. And what's left behind is cosine x minus 2. And that's equal to 0. And we have a multiplication of 2 items. And so we use the product rule of 0, that if you have 2 things that multiply to give you 0, each of those could be, the only way that can happen is for one of them or both of them to become 0. So sine of x is equal to 0, or cosine x minus 2 is equal to 0. Let's deal with this one first, because we saw this a little earlier. Maybe we add 2x to both sides, or 2 to both sides, sorry, just 2. We get cosine x equals 2, which we remember is not possible, so this does not give us a solution. Another way we can test this out is you could try, remember we would have to take the arc cosine of 2, and so if we do that, arc cosine of 2, we see that that's a non-real answer, so that doesn't give us a solution. But over here we have sine x equals 0, so let's get the arc sine of 0. And we see we have one solution at 0, but remember, as is often the case, there may be more than one place where sine is equal to 0. One is at 0, and we look at here, remembering that the inverse sine has only a domain from pi over 2 to negative pi over 2, so it's sort of the east side of the circle, the east half. But then on the west half, there is another place where sine would be 0, and that would be at pi. Okay, so this discussion is sine of x is 0 in two places, 0 radians and pi. Okay, so that gives us our solutions there. So notice it was, today's is really the algebra of trigonometry. We're doing algebra to solve, and then when we get down to it, we're using inverse sines, and when necessary, we use trig identities. But in this case, we didn't need to use an identity. Okay, so let's clear that out. And let's go to this next example. So for this one, we're just looking again from 0 to 2 pi. So theta, our angle is going to be between 0 and 2 pi. But notice we have sine of 3 theta in here. So first of all, we're going to set up, what are we really looking at? Well, our solution for theta has to be between 0 and 2 pi. But we've got a 3 pi, so what is 3 pi? Well, we would multiply each of these sides, or each of these 3 by 3. So what we've got is that 3 theta has to be between 0, 3 times 0, 0, and 6 pi. So that's 3 times around the circle that we can go with 3 theta. So we can treat, basically we do a substitution. We're going to just find what's sine of x, and we're going to say 3 theta equals x, and then we'll come back and we'll solve for theta. So this is kind of a little trick we can do that sort of makes it easier. But x, so theta can only go from 0 to 2 pi, but x, since x is 3 pi, x can go from 0 to 6 pi. Okay, so again, we've got really a very simple solution here. We're going to do an inverse sine to figure out. Again, you may remember that square root of 2 over 2 unit circle, right? We could just look at the unit circle. Square root of 2 over 2 is a 45-degree angle. That's a pi over 4. And that also, we would have that same square root of 2 over 2 on this one, which would be 3 pi over 4. Verifying this, we also get used to coming here, and we can do our arc sine of the square root of 2 divided by 2. Again, oops, I was going, wait, that's not right. I've got to I had a problem with my square root, right? So let's try this again. Arc sine square root of 2. I have to get out of my square root, and then I can divide by 2. There we go. So be careful. I almost didn't see that, but I knew the answer had to be pi over 4. And we come over here to our little 3 dots, and we execute on that. So that's that angle. And again, just remember, domain for inverse sine is only on the east half of the circle, pi over 2 to negative pi over 2. But there is a value on the west side of the circle that will give us the same thing, and so that's going to be 3 pi over 4. So what we've got is we've got that x can be either pi over 4 or 3 pi over 4. But remember, we can go all the x can really go all the way to 6 pi. So let's add 2 pi, and remember that 2 pi is the same thing as 8 pi over 4. And what I'm doing is I'm looking for a common denominator, right? 8 divided by 4 is 2. So the version we're going to use is we're going to add 8 pi to each of these. So because common denominator, just add the numerator. So 8 pi plus 1 pi will give us 9 pi over 4. 8 pi plus 3 pi is going to be 11 pi over 4. So that's one time around the circle. And then we've got one more trip to make, right, to get to 6 pi. So we add 2 pi to each of these two terms, 9 pi and 11 pi. And again, we still use this 8 pi over 4. 8 divided by 4 is 2, so that's 2 pi. 9 plus 8 is 17 pi over 4, and 11 plus 8 is 19 pi over 4. But again, that's all in terms of x. We want it in terms of theta. So to get theta, remember this is 3 theta, we have to divide everything by 3. Or in this case, what we will do is we will multiply by 1/3. That's the same thing as dividing by 3. So our actual answers in terms of theta will be these. So theta becomes equal to 3 times 4 is 12, right? That's there. This one, 3 goes into 3, so it's going to give us pi over 4. 3 goes into 9 3 times, so that's 3 pi over 4. 3 does not go into 11, so we multiply and we get 11 pi over 12. 3 does not go into 17, so we get 17 pi over 12. And 3 does not go into 19, so we get 19 pi over 12. And those are all the answers we have. And if you take these, you multiply it by 3, and you'll see that it will work for all of these, right? And this is with theta staying between 0 and 2 pi. All right. Ready for another one. So here for our example 4, what we see first off is that it looks like a quadratic type equation, right? We've got something squared, so sine x squared, sine x, and there. This looks very much like a quadratic. So what we will do is we'll actually work this without trigonometry at the start. We'll just do a substitution. We'll say that sine x, or sine t, sorry, we'll call that x. Okay, so we make a substitution. Just say, let's use x because then it'll look a little easier. Sine x squared, right? Sine t squared. Sine of x squared, 2x squared, plus 3x plus 1. We're going to solve this for x, and then we will back substitute that x is not really what we wanted. We really wanted sine of t. So let's see, can we factor this equation, this expression? Well, let's try 2x and x, because 2x times x gives us 2x squared. We got to get multiplied by, the back one has to multiply to give us a positive 1, and the middle is positive. So let's try this. 2x times x is 2x squared. 2x times 1 is 2x. 1x. 1x plus 2x is 3x. And then 1 times 1 is 1. So this is the correct factoring. So notice we're all algebra, back to what we did at the beginning part of the course. But we have this product rule of 0, that when you're multiplying two things and they're equal to 0, one of them has to be 0. So 2x plus 1 equals 0, or x plus 1 equals 0. We'll go ahead and solve for x first, because it's in a nice form. So we'll subtract 1 from both sides here, giving us 2x equals negative 1. We'll divide by 2. So we get x equals negative 1/2. We'll subtract 1 from both sides here, and we'll get x equals negative 1. Now, again, x is not what we want. We started off with the sign of t, and we're asked to solve for t, and we don't see any t yet, so we're going to back substitute. Wherever we see an x, we're going to replace it with sign of t. Here, sine of t equals negative 1. And again, we can do these, the question is really what angle t gives us a sine, when we put it into sine, gives us negative 1/2. Hopefully you can remember from the, you can look it up on the unit circle, or we can come here and use our arc sine of negative 1/2. And the reason I like to do this is you might not always have your unit circle with you, but you will be able to use your calculator on all things. And this calculator, we see, okay, pi over 6, negative pi over 6, where's that? It's actually, it's helpful, because what we want to use is we want to be between 0 and 2 pi. So we're not going to use negative pi over 6. That's not the correct answer. It's 11 pi over 6. The other place where it's going to be negative 2 is down in the third quadrant. So that's just a pi plus pi over 6, which is going to give us 7 pi over 6. Okay, so this gives us two answers. We got t equals, we'll write that one, 11 pi over 6 and 7 pi over 6. So that was this one over here. And again, it's not in the domain of inverse sine, so we write it here. Okay, actually, I shouldn't write on my calculator. I might need it for something else, right? Okay, but then what about sine t of negative 1? Okay, so let's back up. Let's go ahead and do the arc sine of negative 1. We see that happens at negative pi over 2. And again, it's always good to come here and take a look at our picture. That's actually 3 pi over 2, right? Because we don't want to, our domain is going from 0 to 2 pi, not including negative angles. So we've also got this angle here, 3 pi over 2, that came from here. So t is also equal to 3 pi over 2. I guess, like, we solved them. So I can put that up here. If you want to put them in order, 3 pi over 2 should be in between them, but it doesn't have to be in order. Okay, so that's all the values for t between 0 and 2 pi. So use your tools and keep going. We've got one more example, and then it'll be your turn. Example number 5, we're going to take a look at this expression, which looks like, it looks kind of like quadratic here, right? We've got secant squared and tangent. Earlier I told you sometimes it's helpful to change everything to terms of sine and cosine, which could work here. But also remembering from our identities that there was a Pythagorean identity. This is an important one to have, all of those Pythagorean identities. Remember that the base one that we work from is that sine squared x plus cosine squared x equals 1. And we derived that also secant squared x is equal to tangent squared x plus 1. So we start with this and we can get to this, but this is one we're going to want to remember. And we can make this substitution then. So we're going to put this in for secant squared. Okay, so secant squared becomes tangent squared x plus 1. And then we had minus tangent x equals 1. So let's clean this up a little bit. We see a 1 on both sides. We could subtract 1 from both sides. That gives us tangent squared x minus tangent x equals 0. And then this is why we don't actually have to go to the cosine and sine, is we can factor out a tangent, because there's tangent squared minus tangent. Factor out a tangent, leaving behind tangent x minus 1. That equals 0. And again, we use our product rule of 0. That gives us that either tangent x, oops, sorry, my n looked more like an x there. Tangent x equals 0, or tan x minus 1 equals 0. So we can do the inverse tangent right here. And again, that's going to happen whenever sine is going to be 0, not cosine, because if cosine were 0, we're dividing by 0, so it has to be where sine is 0, and that would be at 0 and pi, but we'll take a look at that. And then tangent, this one we do a little bit more work. We add 1 to both sides. So plus 1, tangent equals 1, and that's going to happen wherever sine and cosine are the same, right? Because tangent is sine over cosine. But again, we can also just go to our tools here. We're going to go to the calculator. We're going to do arctangent of 0 to start off with. And it gives us the angle 0, but we're going to look at that. See, it's there. Remembering that tangent has a domain same as our arctangent, has the same domain as arcsine, so it's going to go from pi over 2 to negative pi over 2. So it won't include this pi over here. However, if we put in pi, tangent of pi, that's also going to be 0. So we have to remember, and that's from looking at the unit circle. So in this case, we get that x equals 0 and pi. Okay, and we don't have to add because we're sticking between 0 and 2 pi. We don't have to add 2 pi's to these. It's not all the solutions. When is tangent equal to 1? We're going to see that that's going to be the places where sine and cosine are the same. Again, it's going to be helpful for us to go down here. We'll go to the arctangent of 1. That's going to happen at pi over 4. But again, we want to look at our unit circle. So pi over 4, so where would be the other place? We might think it's in the second quadrant or maybe the fourth quadrant, but remember, signs are opposite, so the sine is positive, cosine is negative. Tangent's going to be negative in the second quadrant and the fourth quadrant. Tangent will be positive in the third quadrant. So this one gives us certainly what we see there, x equals pi over 4, but the other one is going to be in the third quadrant. So this is pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. On our unit circle. And so we can just write the 4 answers to this question: 0, pi over 4, pi, and 5 pi over 4. Okay. So that is our lesson, the end of the direct instruction. You'll want to practice these by going through the learning activities in the module. Remember, we do have tutoring available, online tutoring, in-person tutoring. We have my office hours, and also working with peers through the discussion forums and in class here. Thank you.